Since our menu scene seems to be working fine, it is now time to take a look at our level selection scene. And just like before, we will basically just need 3 methods in the level scene class. We will also override the didMoveToView method. And again, I want to have a custom method to add all of the elements to my scene, which I will call setUpLevelSelection, without any parameters. And just like in the menu, I will need an action method for my level buttons, which should of course take us to the appropriate game scene. So let's define a method goToGameScene with a parameter level of type integer. And in this case, we will actually use this parameter from our SpriteKit class, since we will have to determine which level should be loaded here. But how do we load the level? Well, it's pretty much exactly how we got to the level screen from our menu. I will just use my Scene Manager delegate property and call its presentGameScene method, where I will of course have to pass along the level parameter from my method, so that we can load the appropriate game scene for this level. That's all we need in this method. I will now call the setUpLevelSelection method from didMoveToView. And we now want to implement this method that should display our levels with the box buttons in a nice looking grid. So let's just say it will be a 3x3 grid. And you can of course customize this however you like, but then you would of course need to pay close attention to the positioning of the individual buttons, since we are going to do this specifically for a 9-button grid. So, what do we need to implement in this method? To start off, all I want to add here is this button grid to show my levels, and I will need 2 for loops to achieve this. Inside of the for loop, I will also use a level variable, which will also help us with positioning our buttons, meaning the box for level 1 is at position 1, the box for level 2 is at position 2, and so on. So let's define this variable level right here and initially set it to 1. We will later on increase this value to correctly count up all of our levels. I will then define a starting point, or better, 2 coordinates of a starting point. One for x and one for y. In our grid, these values represent the row and the column positions. I'll define a constant called columnStartingPoint, which I set to frame.midx divided by 2. And this will be our x position, and by setting it to this value, I will position this point in the first quarter of my scene. I will then define a constant rowStartingPoint, which will be the y position, which I will set to frame.midY. And then I will add frame.midY divided by 2. This will position this coordinate at about 3/4 the height of my scene. These 2 values combined will put our starting point in the upper left corner of our scene. Now that I have those 3 values, meaning our level value and the 2 starting point coordinates, I can begin defining my for loops. Since I want 3 columns as well as 3 rows, I will write for row in 0 up to less than 3. And inside of this for loop, I will add for column in 0 up to less than 3. With this, I will now add 3 columns for each row and do the same for 3 rows total. Inside of this for loop construct, I now want to begin by creating a level box, which will be the actual button to get into our game, meaning the actual level. I will define a constant level box button as a SpriteKit button instance, which will again need an image, an action, and an index. For the image, we're going to use an image from our asset catalog, where we have this wood button, which is exactly what we want to use. So back in our level scene, Let's add wood button here. The action will of course be go to game scene 4, and for the index, I will pass the current value of level, which will, for our first box, for example, just pass the value 1, which is our first level, obviously. I have now successfully created my button, and I will now have to position it and add it to the scene. So let's start by writing level box button.position, which will of course be a CG point with X and Y coordinates. For the first box, I think it's pretty obvious because the X value will be column starting point and the Y coordinate will be row starting point. This would place our first box correctly. But since we are trying to place multiple boxes here, we will need to change this slightly. So let's take a look at our X position and therefore the columns of our grid. We will need to add something to our column starting point, depending on which column we are currently in. For our 3-column grid, starting in the first quarter of our scene, we will of course want to add this first quarter once for the second column and twice for the third column, which will place them in the middle. And at 3 quarters, we can achieve this pretty easily by simply adding our column starting point itself multiplied with the current column. And since we are counting from 0 to 2 here, this will add nothing in our first column and once and twice the value for the other columns. So let's just add column casted as a CG float times column starting point right here. This will place our first column just at column starting point, the second column at column starting point plus column starting point, and our last column at column starting point plus column starting point times 2. This will give me a quarter, a half, and 3 quarters of my scene. Alright, for the Y coordinates, it's pretty similar, just a bit different. This time we start slightly above the middle, and therefore we want to place the other rows below this, which means we will have to subtract something from our row starting point. And what we want to subtract is exactly a quarter of the height of our scene each time. So we start off at 3 quarters. Then we want to place the second row right in the middle, and the third one at a quarter. So let's subtract the CG float of row times frame dot mid y divided by 2, which will give us a quarter of the height. This has positioned our level box button correctly in our scene. And not just the first one, but every single one we will add with those for loops, and we can then use the add child method to add the button to our scene. Now this has placed a 3x3 grid of box buttons on my screen, but as of now, without any further information. So they all look exactly alike. We should probably at least add a label containing the appropriate number of the level to each one, which we are conveniently able to do inside of the for loops. I will define a constant called level label, which will be a new SKLabel node instance, initialized with a font, and I will once more select Avenir Next Bold as the font. I can then set some properties on my label, starting with the font size, which I will set to 200.0 to make my text rather large, ensuring that it will look crisp on any device. We will scale the text later on, but it is important that it gets scaled down and not up, so it doesn't get blurry. I will also set the vertical alignment mode of my label, which will be set to dot center, and this is to make sure that our label is actually centered in the box and not offset with a baseline positioning. I can then set the text for my level label by setting its text property. And all I want to to contain is the current value of level, which will be 1 at first, and then we're just going to increment it at the bottom here. So that will be 2, 3, and so on for the other boxes. I have already mentioned that we're going to scale our label. So let's do that, since on a small iPhone, the font size 200 would probably be way too big. Therefore, I'm going to call my aspect scale method on level label, and I want to scale it to level box button dot size. So the button that will actually contain the label. Width will be false to scale the label to the height of the button. And for the multiplier, we're going to say 0.5 to make the label half the size of our button. I can then add this label to my button by saying level box button.addChild level label. As soon as I've done that, I can also scale my level box by on level box button, also calling the aspect scale method. And this time we'll scale it to frame.size, and width will be false, and the multiplier will be 0.2. So a fifth of the height, which should work pretty well, given the fact that we have 3 buttons underneath each other. To actually make this work, I will write at the bottom of my for loop level plus equal 1. So that in the next loop, it will add the button for label 2 and so on, until we reach the end of our for loops. Theoretically, this would already work, but since we have in our game view controller specified that the deciding order should be ignored while rendering, we should probably add explicit Z positions to our buttons, as well as labels, to make sure that they are always rendered in the right layer. So to do so, let's head over to our configuration.swift file, where we as of now just have 2 Z positions. So I want to add 2 more. The first will be static let HUD background, and HUD will here just stand for anything that isn't a direct game element. So buttons, labels, menus, overlays, and so on. It will of course also be a CG float. And I want to start off with the value 10 here. Why do I specify 10 here? Well, our HUD elements should generally always have a higher Z position than any game element. And since we might add some more Z positions for the game later on, we'll just jump to 10 to leave some room there for lower Z positions. The second new value will be static let HUD label as a CG float, and it will be set to 11. As soon as I've done that, we can go back to our level scene file and start by adding level box button.z position and setting it to z position.hud background, and down here I will just write level label.z position and set it to z position.hud label. Alright, this should work, and a tap on a level button should take us to the corresponding game scene. Let's test this. So run the app, and if all of this works, we should, just like before, get to the level scene of our menu, but now we should also be able to see our 9 level buttons there, which we can then use to start our game. We do of course only have one actual game scene SKS file at the moment, but since we've used save optional queries in our game view controller, we should hopefully not run into any runtime errors if we click on a level button that doesn't yet have any corresponding level file. So let's take a look. The app started, and a tap on the play button now shows me our 9 level buttons in a 3x3 grid. If I now tap on a label that doesn't yet exist, so maybe 5, I can see that my button is working since the alpha value is changing, but nothing actually happens. And we can check why this is the case in a second. If I tap on 1, however, we will, after a short delay, get to our game scene. And this works perfectly. If I now stop the app and we go back to our game viewcontroller.swift file, we can see why clicks on non-existing levels do not produce any errors. So if I take a look at my present game scene method right here, I can see that we initialize our scene name with the level parameter here. So maybe game scene _5 in this case. This file doesn't exist. If we then, in this if-let statement, try to initialize a scene with it, no actual value is returned. And therefore, the contents of the if-let brackets aren't being executed, which therefore doesn't produce any errors, which is pretty nice. What we now want to do is learn how to create more than one level. Therefore, I'm going to create a new group in my project, which I will call levels. I would then drag my game scene _1.sks file in this group. And how we can add more levels and load them correctly is what we are going to look at next.